Hi and a very good day. So in this example, I will continue discussing textbook example based on box Jenkins method by using R. Right? So now let's take a look at monthly road accidents. Okay, so this is based on page 267 dataset. Okay, now we will investigate whether our series is stationary or not. Okay, right. So this is the way on how can you read the data set into R. Okay, and then again we check the structure of the data set so that we want to ensure R read the data set correctly, right? Okay, so for this example here, what we try to investigate is actually this casualty variables. And that's why next what we do, okay, we define this casualty variable as time series object by using ts function. Okay, again, okay, this is the data set name, this is the variable's name, and then okay, by using ts function we specify the start. Okay, start here we means that you will use C1975-1. Okay, it means that this is for the year, and then this is for the month January 1, February 2, and so on. Okay, and the frequency that we specify here is frequency equals to 12, means that is a monthly data series. And again, what we do, we plot the original series. Alright, so based on this original series, okay, again what we try to look at is whether our original series have trend, have seasonal, or have both. Okay, so the most obvious trend that we have here is actually the most obvious pattern that we have here is actually the trend. Okay, so this original series, as we can see here, register a general upward trend over period of, okay, as we can see, it takes this period 1990 until 2003. Okay, so what we do, we can perform the first difference toward the original series to detrend the trend component, right? Because of what? We know that the trend if our original series have a trend component in there, we can say that the series is not stationary. Okay, so what we do, we can perform the first difference, and then we can plot the first difference. Okay, this is the plot. Okay, this is the monthly road accident after we perform the first difference. Okay, this is the plot. As you can see here, okay, I put different function here, okay, to plot this particular series. Okay, and then to plot this the line here, okay, I feed the linear model, the linear trend. Okay, so this is the way on how can you okay, produce this straight line. Okay, feed lm. Okay, this is the name. Lm here is the function that we use. Okay, this is the variable that we want to plot against time. Okay, against time, and then this is the function to plot this particular straight line. Okay, feed lm, color red, right? Okay, so this is the difference between the original series and the series after we perform the first difference. Right? Okay, next again, when we dealing with the series, it's best for us to proceed with plotting the ACF and PACF for both original and the different series. Because of what? We want to look at the relationship of the series across time. So the best way to find this to find the pattern of this relationship between across time is to plot the ACF and PACF. Right? So based on this ACF and PACF for the original series, okay, as we can see here, the ACF is decaying rather slowly. Okay, decaying rather slowly when the number of flag is keep increasing. Okay, this is okay, when you see this kind of pattern in ACF, we say that the original series is not stationary. And then when we take a look at the PACF here, since that there are especially one significant spike here at leg 1, we say that it suggests the series can be stationary after performing the first difference. Okay, and then after we performing the first difference, we plot the ACF and PACF again. Okay, as we can see here, we plot the ACF and PACF again, right? So here, as we can see here, now even though that okay, for ACF there is actually no obvious pattern, right? So we ignore the first, okay, the leg 0 significant spike here. Okay, for ACF there is no obvious pattern. Okay, but for PACF there is actually a decaying pattern, but this decaying pattern is okay, die rather quickly at okay, at leg 4 here. Okay, and as you can see here, it is actually quickly, the decaying pattern quickly dying out. It means that this is okay, one of the signal means that the monthly causality now is stationary after we perform the first difference. Okay, and again, if you want to confirm this particular stationary characteristic on our series, we can perform tests such as ADF test. Okay, to perform ADF test in our programming, you just use this ADF.test function. Okay, and for this example, I perform ADF test both for, okay, this is original series, and then this is for the first difference of the original series. Okay, so as we can see here, okay, this p value here for the original series is okay, accepting the null hypothesis, whereby the alternative hypothesis is stationary. So it means that the original series is not stationary. Okay, whereby, okay, the p value here is 0.01 for the first difference. Okay, the p value is 0.01, means that we reject the null hypothesis, while okay, means that now the alternative we reject the null hypothesis of non-stationary, means that the conclusion is, okay, we have enough evidence to say that the first difference of accident causality is stationary. Okay, this is the explanation. Alright, so I think that's all for this example. Okay, I will continue my video for pump oil production example. Right, okay, thank you for listening. Bye.